Good day. Uh, this is a mini revision of what I've taught you throughout the semester, and you can use this as a key point to help to tailor your reading when you're preparing for the exam or perhaps the test whenever you are being or assignment given to you. And oh, with the part I focused on during this semester focused on centrally on isolation, purification, characterization of enzyme. I also talked about model of enzyme substrate interaction, which deals with induced fit, lock and key model. Those are the things I covered during the semester. Now, when I also talked about isolation, purification, characterization of enzyme, I also covered cell disruption. After cell disruption, talk about centrifugation, removal of supernatant. You talked about uh, salt ammonium sulfur precipitation, that's this precipitating your protein out of the solution. We talked about dialysis and followed by chromatography technique, which is an ancient method used, it's still used today because it's highly relevant. It's still used to purify protein of interest or enzyme of interest from a wide varieties of sources. And so this PowerPoint are just there to serve as a key point to help you to be able to connect what I've taught you in the past. Now, the most important thing is that you should learn to calculate the progression of your protein purification or enzyme purification as you move from one stage to the other. The reason behind this is that you should be able to monitor that your protein of interest will be preserved from being eliminated during the protein purification exercise. If this is not done, you'll find out that at the end of your production processes that your protein of interest is lost, and that means you have to start the rigorous exercise of purifying your protein all over again. But in order for you not to go through this strenuous exercise again, this calculation has been made in order for you to be able to monitor your process. A typical example is this table that contains an enzyme of activities. Now, in these tables, in some tables, you will have volume, protein, activities, total proteins, total activity, a specific activity, yield, and purification. In another table, you might not have the volume, you might not have the protein, you might not have the activity. It can start from total protein, total activity, specific. These are variations, and in some ways they may not present it in form of a table. It might be presented in form of a write-up and ask you to calculate your desired whatever question you are being provided. But every variable on this table is very important. Now, whereas the column, the first column is telling you about stages of the purification techniques that was adopted. We have the homogenization, we have the salt fractionation, we have the ion exchange chromatography, we have the gel filtration, and we have the affinity chromatography. I want you to take a closer look with that of the homogenization, and then we will look at the affinity chromatography, so that with that you can be able to solve the ones in between. Now, for volume, the volume is essential in order for us to be able to calculate the total activity and the total protein. Now, like for the total protein, which means that the total protein contained in 500 when your mixture was collected, the total volume was measured, which is 500 ml. Now, you carry out the protein assay to determine the protein concentration using a protein standard curve to know the exact quantity of protein present in it. And when you measure that, it was 30 milligram per ml. Now, how do you know the total protein present in that mixture when you have 500 ml? The mathematics behind it is to calculate the total protein, which is 500 times 30, and invariably that will give you 15 thousand milligram of protein present in 500 ml of your uh, crude protein. Then when you look at the activity, after depending on the assay, which will tell you how you can be able to calculate your assay, and that is measured in units per meal. And the total the activity for this particular enzyme is 300. So for you to know the total activity of the enzyme contained in 500 ml will be 500 times 300, and the total activity will give you 150,000 units. Remember, when you look at the units, it can also help you to be able to know which one to eradicate. How do you multiply? Like now, when you see that 500 mil multiplying unit per mil, you will invariably the mil is cancelling out the mil. That's why the unit for total activity is in units, which can be represented as U, and that of total protein is represented as milligram. When you look at it, volume times protein, which is in milligram per mil, the mil cancel out that, and you are able to get your 15,000. Now, how do you calculate your specific activity? The specific activity is your total activity divided by the total protein. The specific activity is total activity divided by the total protein, which is, when you see it, 150,000 divided by 15,000, it will give you 10 units per milligram. 10 units per milligram. Then the question is, how do you calculate your yield? Your yield is calculated by using total activity. Now, the total activity of the stage you are working on divided by the total activity of the crude. Are you getting me? I come again. The yield is gotten from the total activity of whatever purification stage you have. For example, if you are doing ion exchange, then the total the yield is okay. For example, you are doing that of affinity chromatography. The yield is 52,500 divided by, that's the total activity of that stage, divided by the total activity of the crude, which is 150,000. And by the time you multiply it, you multiply it by 100. When you divide 52,500 divided by 150,000, it will give you 0.35. And by the time you multiply it with 100, it will give you 35%. That is how you calculate your yield. The same thing applies to that of what's it called? That of gel filtration, which is 75,000 divided by 150. And you bear with from your arithmetics, 75,000 times 2 will give you 150. So that's 75,000 divided by that's 0.5. 0.5 times 100 is 50%. So through that, you will be able to know that your yield is calculated by total activity of that particular stage of purification over the total activity of the crude that you started with, and that you can be able to calculate your yield. Now, how do you calculate your purification fold? Now, your purification fold make use of specific activity, which is the specific activity of the particular purification stage you are over the specific activity of the initial or crude content. For example, if you have the purification fold for the crude, the homogenization stage is 10 over 10, which will give you 1. Now, when you want to calculate the specific activity for the purification fold for the affinity chromatography, it will be 30,000. That is the specific activity for that particular stage divided by the specific activity for the initial stage, for the first stage, which is the crude. That is 30,000 divided by 10, and you see that the purification fold is 3,000. If you take your calculator, take time to internalize this table and to understand it, and look at how, whatever form it can come, Try to understand the formulas, and this will help you to be able to answer your questions when the time comes. I wish you the best in your exam, and if there are questions, kindly contact your class rep or comment under this video. The answers will be given directly and made clearer. Thank you very much.